Hi everyone. Today's topic is overchaining. First of all, we have to know what is forward chaining. Forward chaining is forward chaining in artificial intelligence is a method in which inference rules are applied to existing data to extract additional data until an end goal is achieved. In this type of chaining, literally in this type of chaining, the inference engine first evaluates existing facts, derivations, and conditions before deducing the new information. This is the basic concept of the forward chaining. Here, get into the topic. Now, forward chaining is a data-driven method of deriving a particular goal from the given knowledge base and set of inference rules. Inference rules are applied by matching facts to the antecedents of consequence relations in the knowledge base. The application of inference rules results in the new knowledge from the consequence of the relations match, which is then added to the knowledge base. Forward chaining. It is a strategy of an expert system to answer the question what is happen next, what can happen next. The inference engine follows the chain and derivation. Sorry, one second. Okay. Here, here the interface engine follows the chain of conditions and derivations and finally reduces the outcome. It considers all the facts and rules and sorts them before concluding to a solution. This strategy is followed for working on conclusion, result, or effect. For example, prediction of share market status has an effect of changes in interest rates. Means this can be a predictable one, and for predicting those changes in the stock market or anything, it will analyzes the existing facts and rules and clauses and the inference rules. Now, in forward chaining, the system starts from a set of facts and set of rules and tries to find a way of using those rules and facts to deduce a conclusion or come up with a suitable course of action. This is known as data-driven reasoning because of the reasoning starts from a set of data and ends up at the goal, which is conclusion. The mechanism of the forward chain. When applying forward chain, the first step is to take the facts in the fact database and see if any combination of these matches all the antecedents of one of the rules in the rule database. When all the antecedents of a rule are matched by facts in the database, then this rule is triggered. Usually, when a rule is triggered, it is the then fired, which means its conclusion is added up to the facts database. If the conclusion of the rule that has fired in an action or a recommendation, then the system may cause that action to take place or the recommendation to be made. Example for forward chaining. Rule 1. If on first floor and button is pressed on first floor, then open door. Rule 2. If on first floor and button is pressed on second floor, then go to second floor. Rule 3. If on first floor and button is pressed on third floor, then go to third floor. This is generally the rule system for a lift in any building. And rule 4. On second floor, if on second floor and button is pressed on the first floor and already going to the third floor, remember to go first floor later. Let us imagine that we start with the following facts in our database. Fact 1, at first floor. Fact 2, button pressed it on third floor. Fact 3, today is Tuesday. Now, the system examines the rules and finds that fact 1 and fact antecedents of rule 3. Hence, rule 3 fires and its conclusion go to third floor. Is added to the database of facts. Presumably, this results in elevator heading toward the third floor. Note that fact 3 was ignored altogether because it doesn't match with the antecedents of the any rules existed. Now let us imagine that the elevator is on its way to the third floor and is being reached to the second floor when the button is pressed on first floor. The fact button pressed on the first floor is now added to the database, which results in the rule 4 filing. Now let's imagine that later in the day, the facts database contains the following information. At first floor, button pressed on the second floor, button pressed on the third floor. In this case, new rules are triggered. Rule 2 and 3 in such cases where there is more than one possible conclusion. Conflict resolution needs to be applied to decide which rule to file. Forward chaining applies a set of rules and facts to deduce whatever conclusions can be derived, which is useful when a set of facts are present. But you do not know what conclusions you are trying to prove. In some cases, forward chaining can be inefficient because it may end up proving a number of conclusions that are not currently interesting. In such cases where a single specific conclusion is to be proved, backward chaining is more appropriate. Okay. Forward chaining with another example, weather forecast system. Here we can see we have developed the following rules for our weather forecasting system. If we suspect temperature is less than 20 degrees and there is humidity in the air, then there is a chances of rain. If sun is behind the clouds and air is very cool, then we suspect temperature is less than 20. If air is very heavy, then there is humidity in air. Suppose we have been given the following facts. Sun is behind clouds and air is very heavy, but very heavy and cool. Then problem using forward chaining, try to conclude that there are chances of rain. First one. Okay. We suspect temperature is less than 20 degrees and the status is unknown. Then working memory will be sun is behind the clouds and the air is very cold and heavy. There is humidity in the air and the status is still unknown and the working memory will be same as the previous one. And the third case will be sun is behind the clouds and status will be true and working memories will be again the same one. And the fourth case is air is very cool. True fire rule, the status will be the true and fire the rule. So that we suspect temperature is less than 20 degrees. Okay. Now, here again, second pass, when we go for the second pass, we suspect temperature is less than 20 degrees and the status is true, and the working memory will be same as the previous one. And the third case, there is humidity in the air and the status is unknown. And the working memory will be still the same as the previous one, and the air is very heavy. Then the status will be true, and the fire will and the rule will be fired. And the working memory will be added with another fact that there is humidity in the air. Now, another pass in the third pass, we suspect temperature is less than 20 degrees and the status is true and the working memory is the same as the previous one. Then in the second case, there is humidity in the air and the status will be true and the rule will be fired. And another rule is added to the working memory is there are chances of rain. Hence, means this is the proving. This is the method to prove that there is chances of rain in the given conditions. And these are the examples so that we can understand the power changing mechanism and the methodology. And this is the end of today's session. Thank you.